Hi everyone, my name is Bassem Yacoube. I'm a solutions architect with OctoML. And today we're going to be talking about how you can build your applications. We're using Llama 2 endpoints on Octo AI and the LangChain stack. So this is very quickly the agenda. So I'm going to talk briefly about what is the Octo AI platform, then go over a couple of RAG concepts, and then we'll show a few demos about doing RAG using LangChain and the Octo AI Llama endpoints. And then I'm going to tell you about our text gen innovation program that we're just starting at Octo right now. So very quickly, at Octo AI, we are all about making it easier for developer and practitioners to run, tune, and scale your applications. So we just want you to be able to get an endpoint for your model, whether that's an open source model, out of the box foundational model, or bring your own model. You can run it on our platform. You can tune it, and we already have tuning for Stable Diffusion out now, and we are adding tuning for LLMs in the next few weeks. And you can scale that in production to several replicas, several nodes to support your workload. Okay, so like I said, we have an image gen solution now for Stable Diffusion 1.5 and SDXL. We have 3 Llama 2 models and a bunch of others that I'm going to show you in a second. And we've built all the cloud infrastructure, so all these models are already optimized and running on our cloud. So you just go sign up and get an API endpoint that you can start using in your application right away. So what's the text innovation program? So basically that's a new initiative that we're starting. We're looking for customers or users or developers that will work with our product and engineering team. And we will help you solve your problem, and you can help us shape the product, shape our offering of our text generation platform. It comes with a bunch of perks, like you get free weeks of unlimited usage on Llama 2 endpoints, and you get to work with our product and engineering team. Okay, so let me show you what is the Octo AI platform very quickly here. So if you have your laptop or your phone, you would like to do this right now, it's octoai.cloud. So if you go to octoai.cloud, it will ask you to sign up. You can sign up with your Google account or your GitHub account. It just takes a minute. And then you should see a screen that looks like this. So we have example models, and these are basically the templates that we already have on the platform. So the first page you can see some image gen models here, and our Llama 2 13B. And the one that we're going to focus on today is on the second page, the Llama 2 7B. You see we also have like a bunch of other models like Llama 2 7TB. We have text embeddings using Instruct. We have WhisperX for audio, text to video with zero scope, and so on. And there is also a way for you to bring your own container, your own model. You can read more about that in the docs. We also have a very active Discord channel, so you're welcome to sign in and start asking questions and interacting with the team. And finally, you can talk to us directly in the chat box. This goes to our customer success team directly. So this is how you can sign up and get support. And you get $10 free credit, which are good for almost 10 hours of the A10G GPU instances. Okay, so if you want to follow along, we're going to be creating a Llama 2 7B model. Okay, the internet is a little slow. Okay. All right, I'm not sure why this is not showing up for me. I already have an endpoint, but for those of you who are trying to create one, I hope it's working for you. Okay, so I'll go back to a couple slides and then we'll jump into the code. So Llama 2, as you know, Meta released it about a couple of months ago. It's currently the strongest open source LLM. We have optimized those 3 variants, 7B, 13B, and 17B. And we have them as endpoints in our cloud, as you just saw. Our performance testing shows that across the board, we have anywhere from like 20% to 100% increase in throughput in tokens per second generated for the different variations of the model. Okay, so very quickly, what is RAG? So it's retrieval augmented generation. Basically, the LLMs, have a problem with the training cutoff or the data that they haven't seen before. So we want to provide them more background data, more context data when we're doing a query to give them more information that they can use to answer the question. So on a conceptual level, it's like a retriever generator components. You can think of the retriever as your inspector that does a pre-search in the data source, in the knowledge base, and then retrieves the information that's relevant to your query. And then you have the generator, which takes all this relevant context information plus the query and generates an output. So the very common example, you've probably seen that before, is chatting with a PDF. So you want to be able to upload your document, and then your model will be able to understand it, and then you issue a query, and the model should be able to give you a response from the information in that document. So continuing with this example, the different components will be something like this. So the document will be chunked into different text chunks, and there are various algorithms and tools to do that. And then we're going to generate the embeddings. The embeddings are just numerical vector representations of that text. There are embeddings models that are different from the LLM models. So 2 kinds of models are needed to create the RAG application. And we also have embeddings model on our platform. So I'll show you that in a second. Once you have the embeddings, then you usually store those in a vector DB or a vector store. There are different kinds of those. So there's one like ChromaDB that's embedded inside LangChain. There is LlamaIndex comes with one. And there are also some that are completely external products that are cloud-based or on-prem, and you can scale them to very large number of instances and users. Like Pinecone and Melvus and so on. So once the user issues the prompt gets embedded through the same embedding model, and then it makes a vector search query to the database. It retrieves the relevant text to that query, and then the query and the retrieved information from the database are sent to the LLM, which then weaves the narrative and creates the response. Okay, so let's see a few examples of doing this. Okay, so this code, by the way, sorry, I should have. Okay, so all this code is in this repo. It's github.com/octoml/hackathon2023 rag. So the code is available there, all three examples that I'm going to show today, and it's going to, this repo will be up, so you can follow up later if you want to try those yourself. So the first one, I just wanted to check if my endpoint is working and my OAuth token. So when you clone this repo, you're going to see an env file. So in this env file, you're going to put your endpoint URL and your Octo AI token. And the way you get those is okay, let's see if this is working now. Interesting. That's very interesting. Okay. Okay. Good. All right. Maybe there's something wrong. Okay, just moving on. I don't know what's causing this issue, but once you have the endpoint, it's going to look something like this, and you can generate a token from your profile settings on the site as well. It should look something like that. So this is my Llama 2 7B endpoint. And the first Python script here, the chat main, so all I'm doing is just creating a LangChain object and passing a system prompt that says, these are the instructions, write a response, and just using the LangChain prompt template and passing it a question. So we already have LangChain providers for LLM endpoints and for the embeddings endpoints. So if you do pip install LangChain, you automatically will have the Octo AI endpoint and the Octo AI embeddings object. So here I'm directly just instantiating this LangChain object for the Octo AI endpoint, giving it some parameters, and it's going to use the URL and the token needed. So you run this, you're going to get something like that. So this is not doing RAG right now. This is just the model responding to a general information question. So who's Leonardo da Vinci? And it says, he's a Renaissance artist and polymath, etc. So now I'm sure that my endpoint and my token are working. So the next example is going to do RAG. So okay, so here we're using the LangChain, the LLM model, the embeddings model, and the vector stores. I'm using Feis for this example. Feis is also a package by Meta that does vector storage and vector search. So here, I'm pointing it to a PDF file. This PDF file is just a free open source novel, a Sherlock Holmes novel by Arthur Conan Doyle. And it's just 15 pages for the sake of the demo. So it's going to read the PDF and allow me to ask questions about the PDF. So So I ran the code, it created the embeddings, stored them in the FICE storage, and now it says, ask anything about the document. So let's see if we can ask it a couple of questions about this document. So who's the author of the book? Okay, so it says based on the text provided, the author is Arthur Conan Doyle, which is correct. What's the book about? Okay, let's try that again. Okay, so again, based on the text provided, the book is a mystery or detective story, which is correct. Okay, and let's try another one. So who is the murderer? Okay. Okay, so it couldn't guess this one, but obviously it shows that it's reading the information from the PDF. So that's very simple example of how we can do RAG on a PDF file. The last example I'm going to show here is a little bit more complex, and it's the one in the web retriever folder of the GitHub. So here I have two data sources, our own OctoAI documentation and the Kubernetes documentation. And I created a web crawler that just crawled all the URLs for the OctoAI docs and the Kubernetes docs. And then I used the same framework, LangChain and ChromaDB, and created the embeddings. So I already have the SQL files for ChromaDB for the information in the OctoAI docs and the Kubernetes docs. And now here the code file. I'm going to be calling two models in parallel. So I want to test the Llama 2 7TB against the Llama 2 7B and see what's the difference, in quality and performance. And you can do this for a lot of, other situations if you want to test against ChatGPT or any other model. So again, using the LangChain LLM providers for the OctoAI endpoints and passing the two endpoints, endpoint URLs and my authentication token. And all the code for doing the embeddings and storing everything in the database is here as well, but I'm not going to cover this right now for the sake of time. Okay. So run this. We're going to see something like that. So we have the response from Llama 2 70B and the response from Llama 2 7B. So I asked it a question about how to reduce cold starts, and I pointed it to our documentation, the OctoAI docs. And so basically went through all our docs and found the different solutions to reduce reduce cold starts. So things like using volumes, using warm-up script, smaller container size, pre-built images, and so on. And you can see there is a difference in quality. I usually find 7TB to be more concise. It usually gets to the heart of the problem, if you will. We are going to announce the option to run 7TB on multiple GPUs So the response time is going to be better than that. So here, I mean, obviously, if you're running on a single GPU, 7B is going to be faster. But yeah, we are providing multi-GPU for 7TB in the next couple of weeks. So hopefully you'll see faster responses here. Okay, so the last thing I wanted to show is how we can deploy this into AWS as an application. So now we have a container that, we have the code that calls the Llama 2 endpoints and the embeddings models. Let's say we want to publish that into an AWS application and have it hosted in the cloud. So a very quick way to do this is using AWS Lambda functions. So the way to create an AWS Lambda function for something that is as big as this. This, by the way, like once you install LangChain and ChromaDB and all the other requirements, it's going to be about 2 to 3 gigs in size. So it's not going to fit in the regular Lambda function. So I'm using the container image type of the Lambda functions. So I'm building an AWS container based on the Amazon Linux image, and then just copying my code and requirements and installing the requirements here. And if you have noticed, my code has a handler function, which is the entry point of the Lambda, and it's going to return the answer as JSON. So these are the requirements of the Lambda function. After doing this, you can use something like the SAM, AWS SAM framework to build this container and deploy it for you as a Lambda function. So after installing SAM, you point it to that folder and do a SAM build. So this is going to basically look at that Docker file and create a container. Okay, so it created the different layers of the container here, and this build succeeded. You can test it locally by doing something like SAM local invoke. So this is going to run the code from the container that it just built. Okay, and it should ask the same question, how to reduce cold starts. Let's give it another second. Okay, so here we got the response as JSON, since this is going to be a Lambda function, but you can see we have the first response from the Llama 2 7TB, and then somewhere here we should have the Llama 2 7B response. So basically the same code has been run in a simulated Lambda function. So now if you want to deploy this in AWS, so you do something called SAM deploy /guided, and then it will keep asking you a few questions about your stack name, your AWS region, and so on. After you answer these questions, it's going to basically push this container into the AWS ECR, the Elastic Container Registry. Just to show you that the container that was generated, so if I go here and okay, so these are the images. Okay, so if you run Docker images, you can see here the images that were generated right now when we ran SAM. So again, if you do the SAM deploy, this will push that to your ECR registry, which will look something like this. So this is my container image here. And then the last step would be to copy this URI and go create a Lambda function. And when you create a Lambda function, you're going to select the container image, give it a name, and post that URI here, and hit create function. So that will use the uploaded Docker image to create a Lambda function. It's going to look something like this. So this is my Llama 2 Lambda. And just to make sure that it's working, you can go in your test tab and run a test. So now this is running the same code, which uses the Octo AI, Llama 2 endpoint, and LangChain on the container in AWS Lambda function. Okay, so looks like the call succeeded here as well. So now the Lambda function was able to talk to my 7TB endpoint and get a response, and also called my 7B endpoint, and here's the response. So now this is your application deployed in the cloud. You can easily just create an API gateway in front of this Lambda function and give the URL to your customers or front-end developers to build an application. All right. So this concludes my demos here. I wanted to just recap. The benefits is now, as you can see, you can create models very quickly using the endpoints on Octo AI without having to worry about infrastructure or how are you going to get the GPUs for your models. You can move to production easily by selecting the number of replicas for your endpoint, and you can easily containerize these applications and deploy them to a public cloud, like I just showed you with AWS. So you can really start building your applications in minutes versus days or weeks. So happy to take any questions, but I want to put this slide on in case anybody here wants to sign up for the TextGen Innovation Program. Like I said, you get a Llama 2 API endpoint with no access limit for 4 weeks, and you get the opportunity to work directly with our engineering team as well. So looking forward to having everybody join that program. Thank you.